Hello, my name is Frank Elsen and I'm the electrophysiology applications scientist at Harvard Bioscience. This video is about the new HEKA software PATCHMASTER NEXT. It is about the new features of PATCHMASTER NEXT, so I will not explain all the details of PATCHMASTER NEXT in this video. Here's an overview of what's to come, so please feel free to step ahead. I want to start with the first part, which is the user-specified startup conditions. As you know, most labs have multiple users on one setup. So PATCHMASTER NEXT allows each user to create their own specific configuration settings and to load PATCHMASTER NEXT with those settings. So you have multiple users, and when you start PATCHMASTER NEXT, you see there's a list of configuration files available. You can select one, and like I said, each user should create their own configuration file, and you can also give it a description down here. But you select the configuration file, you load it by pressing this button. New users, I would suggest to use the Use Defaults button. That starts PATCHMASTER NEXT with its default settings. Then this hardware selection window comes up. On the left-hand side, you see there is the hardware automatically selected that is connected to the software at this moment. And also the interface should be automatically selected by the software. And all you need to do is now press continue. Then this little welcome window comes up under the default settings, which can be disabled. But for now, I would press continue. And the first thing that a new user should do is save the configuration file with their own name. So you go to the configuration window, open it by pressing this button, and then you save a new file by pressing Save As with a new name. Next time that file will be available for you to select. Okay, so the basic difference between PATCHMASTER NEXT and PATCHMASTER is the graphical user interface. There are many different kinds of things, but here are 4 topics that I would like to introduce. The right mouse click functionality is one of those. What do I mean by that? Well, if you look, for example, at the oscilloscope window, depending on where you click on the oscilloscope window with a right mouse click, then you have different functions. But before we get there, let's have a quick look at the top buttons here. For example, this button, when you click on it, it opens a drop-down menu with display-related options. Then there are these 3 buttons here that allow you to analyze the data trace that is being displayed. And then there's this button here that says Traces. When you click on that button, the Trace Properties window pops up. Again, an important window to actually modify or adjust the display settings. Now, the right mouse click. If you, for example, right mouse click anywhere in the display here, then options pop up for actions that you might want to do. Further options are down here. If you, for example, click down here in this area, then other commands or options will be available. So in general, I would suggest to right mouse click on a window and see what pops up in the respective area. Then there are one-click action buttons. These are the top row buttons on each window. And those buttons, they have basically 2 different kinds of functionalities. One is that they open or close a window or drop-down menu, and other buttons, they might simply execute a command or an instruction. Here you see the top row buttons of the control window or the main window, and let's have a closer look at this button here. So you see this button has this little black triangle, and every time you see this little black triangle, that means this is a drop-down menu button. So when you click it, it will open a drop-down menu. Then there's this amplifier window, for example. Again, it has 3 top row buttons. Looking at the copy rpip button, this is a button that executes a command. And what it does, it copies the rmemp value to the pip resistance field in the data parameter window. The data parameter window is a window that carries all the metadata that are being automatically saved to the recorded data. And the pip resistance is, of course, one of those values that is important to report when you want to submit a paper. So pressing this button will copy the rmemp field, or the value of the rmemp field, to the pip resistance field. Then there's this reset button, another very helpful button, because when you want to start a new recording, you simply press this button to reset the amplifier to its start values, and then you can patch the next cell. Then there are tweak buttons. Almost every window has a tweak button that is specific to the respective window. And again, they have different functionalities. Some allow you to customize the functionality and the display of the respective window, or some give you access to additional tools or specific settings for that respective window. Here we have, for example, the amplifier window again, and there's the tweak button. So when you press on the tweak button, it opens a side window, and here you see on top different tabs with different functions. The view tab, for example, allows you to customize what kind of functionality is actually being displayed in the amplifier window. In the hardware tab, you have other options to specifically set the functionality of the attached amplifier. And then under the tools tab, you have additional software access to other programs, like, for example, calibrating routines for the amplifier and head stage, or analysis routines of the hardware, where you can do full test to check the hardware. Then depending, like I said, depending on the window, the tweak buttons have different kind of functionalities. If you press the tweak button in the data tree window, you have 2 options here. Again, a view option where you can modify the view of the window itself, what is available on there. And then there's the export button here, or the export tab, where you can specify the export format of the data. And then there's the drag and drop functionality, which is mostly being used for the protocol editor. This functionality allows you to create very easily complex protocols or scripts. Here we have the protocol editor window. And with all windows, the protocol editor has allows you to save a support file, the protocol file, where you can make your changes for the protocols that you create. The same is true with the stimulus editor, where you can change the stimulus sequences and then save all your stimulus sequences in one file. And the same is also true with the analysis editor. So in general, when you use protocol editor, analysis, or stimulus editor, I would always recommend that the user saves first their own file. Do not save your changes into the default file. So to do this, all you need to do is you go on the Save As button, you click on it, and you give the file a name, and then you save it. And now every change that you would make is being saved to the support file with the name Frank. Okay, the buttons on top, there are some buttons that, for example, the macro recording buttons, they are being used to easily record complex actions and sequences that you would like to automate. Then there is this button over here that's called APROT, stands for Amplifier Protocols. It's a toggle switch, so when you click on it, it will give you access to the amplifier protocols that can now also be modified and adjusted right here. If you click on it again, then it goes back to the view of the other protocols. And how do you now create a new protocol? It's pretty straightforward. You press on the little plus button. Then you can also rename it, which I did here. I called it IV steps. And here I would like to just now do a small little protocol, create a small little protocol that would execute a stimulation sequence multiple times. So to do this now, I go into the acquisition part, click on acquisition. I go over to the acquire series. And now I double click on the acquire series, which adds that command to the protocol column. And there are these two options now. You can add a command from the protocol events column into the protocol column by double clicking on it, and it will be added to the bottom of the list. Or you can left click, hold it, and drag it over to the protocol list. Here I double clicked on it, and as you can see, series appeared. And now I can select the stimulation sequence that is associated with this recording. Now, as I said, I would like to repeat this recording a couple of times. To do this, I have to add a repeat loop. Again, I can double click on the repeat loop or drag drop it. So I double click on it, and it will enter that repeat loop command into the bottom of the series. Now I need to grab the series and drop it onto the repeat to put it inside the repeat loop. And you see that whatever is slightly indented is inside the repeat loop now. Then I can choose how many times would I like to repeat this repeat loop, 5 times, for example. But I do not want to run this series IV 5 times in a row, one after the other. I want to wait, let's say 60 seconds in between each series recording. Now I can add this command. And this time I would like to drag drop it to show you how that is done. Again, I could double click on it and it would add the command to the bottom of the series. Or in this case now, I left click, hold the wait command and move it over. And I drop it onto the repeat loop to enter it into the repeat loop. And then I can set the time of the command, of the wait command, let's say 60 seconds. And as a last step, I would like to add a very nice feature here that allows me to monitor the quality of the recording configuration. As you know, it is important to keep an eye on the serial resistance, for example, one of those parameters that is very important to keep an eye on while you're doing a recording. And to update the value of the serial resistance, you need to press the Auto See Slow button in the amplifier window. We can do this automatically. So you click on this button, Hardware, you select the amplifier command, and again, I could now drag drop it, or in this case, I double click on it. It appears on the bottom of the sequence. And now, of course, it doesn't really help me to have the update of the serial resistance after I did the recording. I actually would like to update the serial resistance, which is automatically saved, of course, with the metadata, before the series recording. To do this, I would grab the amplifier command and drag it into the first position. And now I can tell the software what do you want to do with this amplifier command, and I just check the See Slow button. Okay, this created a very small protocol, but very powerful. What does it do? It basically executes 5 times in a row the following. It will first press the Auto See Slow button to update the serial resistance value, which is then being saved to the next recording. And that recording would be an IV step protocol, or sorry, stimulation sequence. And then The protocol will wait 60 seconds before repeating this sequence. Very easily done and a very powerful thing, the protocol editor. There are other windows that I just quickly would like to show. For example, the stimulus editor and the analysis method, and the analysis editor. Here, the stimulus editor, again, it's very straightforward. I don't explain all the details. On top, you have the timing options that you can change here. In the green area, you have the output and the input channels, the digital analog out, where the command comes from, and then the analog digital in can be set here. By selecting the different tabs, you have access to the different kinds of channels. Then in the yellow field, you can specify the sequence itself by adding and changing the segments. And when you select the segment, you can then also further specify it with the segment editor. When you click on this, it opens up a new window, and it's the segment editor which allows you more specific settings for each segment. Then there is, of course, also right mouse click functionalities in this window. Depending on where you click on the window, you have different options. Then the analysis window, also very easy to use. Again, you have many different methods, and each analysis method can have many different functions that are all executed at the same time. And those functions are available down here. When you click on this editor button, the analysis functions window pops up, which allows you to select different analysis functions. Then on top, the functions and the graphs tab that allows you to select or to work on the functions or the graphs. So you can also change the appearance of the analysis graphs right here. Then the next difference, big difference really to the old PATCHMASTER, in PATCHMASTER Next allows you now to analyze spontaneous action potentials. So here we see again the control window, and there's the events button. And this events button becomes available when there is an PATCHMASTER Next protection key plugged into the same computer. So to have this function available, you need to have also a PATCHMASTER Next protection key being plugged into the same computer. Then the events button becomes available, and when you press it, it will open up the event detection window. And here you see action potentials being detected. The top is, of course, the display of the detection. On the bottom, you have multiple options to set the analysis parameters. And then on the right, you, of course, have a graph that allows you to display the data of interest and also to export it. Then another function that is new in PATCHMASTER Next is the separate oscilloscope for the test pulse. Here again, the control window, and to activate the test pulse and to automatically then switch on the test pulse oscilloscope, you press this button. It's a toggle switch. You press it, it switches the test pulse on and displays the oscilloscope. You press it again, it switches it off. This is the test pulse oscilloscope. And here you see the protocol buttons for the amplifier. These are the automatic protocol buttons that are available when you want to establish patch clamp recording configurations. And here you set the amplitude of the test pulse, and down there, of course, the specifics of the test pulse. And over here is an important feature. This allows you to scale the test pulse and the test pulse only. So you can increase the test pulse by setting this to 5x, for example, that increases the current response for the test pulse. But important to note is here that this scaling does not affect the data scaling in the oscilloscope, in the data oscilloscope. So this is important. There's a big difference to the old PATCHMASTER. When you change the test pulse scaling, it does not affect the data oscilloscope. Then again, we have tweak buttons, of course. When you click on that, you see then there's a tweak option opening up, and like before, you have a view option here, and there are three different functionalities for the test pulse oscilloscope. The test pulse itself, of course, then there is a cell parameter analysis. When you click on it, it will change the display and looks slightly different. You see on the bottom the three green display fields, cell membrane, cell resistance, and the serial resistance are being displayed. Then there's another option that says noise. When you select that option, it allows you to actually see the noise that is being measured in the system at this configuration. Then there's another option, which is the use of multiple displays. So you can create a workspace across multiple displays, which is very helpful. So let's say you have two displays, and when you start PATCHMASTER, it starts up in one display first time. So this is the display, or the default view of the display when PATCHMASTER starts for the first time, or when you press use defaults. Now you can go and change whatever you want. You can move, for example, the data tree over here. You can readjust the notebook window. You can adjust anything you want. And I would recommend doing so, but then also don't forget to save the configuration file like I explained in the beginning with a new name. Then Stimulus Editor, depending on where you open it, the program will remember where you opened the Stimulus Editor, the size of the window, things like this. The same is true, of course, for Analysis Editor and also for a Protocol Editor. In addition, you can, of course, add further windows that are usually not being displayed. For example, when you press on this button, it opens up the Windows display for other windows to be opened. For example, if you are interested in the data parameters to be displayed at all times, you click on it, the data parameter window opens up, and then you can adjust it and place it where you want it to be. You save the configuration file, and the next time you open PATCHMASTER with this configuration file, it will display like you see it now here. Then the last thing is the color coding of the data traces. It's very easy now to at one glance see the correlation between the data traces and the analysis, for example. Here you see that the data traces are color coded in the data tree window. And they are the same color, for example, then when you display them in the oscilloscope window. Here we see that there's a third trace, the leak trace are not being displayed at this moment, and you can do this, of course, by going to the oscilloscope button. You click on it, and if you now select show P/N leak traces, it will also display the leak traces. And as you can see, all of those traces are color coded, so the leak traces are in green. Then if you want to actually engage the subtraction of the leak traces, that is done here. If you click on it, then now you see the results, which is the blue IMON trace is now being shown as well in the oscilloscope after the leak traces have been applied to the IMON trace. How to change the colors is also pretty straightforward. You can do that. You go to the configuration window, open it, and then under the Trace Color tab, there is the option to change the colors to your liking, and you can, of course, save those changes in a set file as well. This concludes the part about the PATCHMASTER NEXT software. I would like to quickly show you one slide more about the new hardware. And this is very fast, just a couple of words about the new EPC10 USB 3.0 amplifiers. Amplifier selection wise, we have now 3 different kinds. We have the single amplifier with one single recording channel. Then of course we have the double amplifier with 2. And we have the quattro with 4 recording channels. No longer available is the triple. Another thing that is important to note here is that these amplifiers, the EPC10 USB 3.0 amplifiers, can only be operated with PATCHMASTER NEXT, not with PATCHMASTER. The main difference between the old amplifier and the new amplifiers is the interface. The new interface, the LRH816. One important part to note here is that all the amplifiers have the same layout of the interface. Let's have a quick look at the interface layout itself. First of all channels have a maximum acquisition frequency of 2 megahertz, 2000 kilohertz, all channels. Then the interface board has 16 digital out channels. 3 of those 16 are available in the front panel. All 16 are available when you turn the amplifier around. You see there's a DB25 on the rear panel. All 16 digital out channels are available here. Then you have a trigger input plug and you have digital in channels. And again, the interface board has 16 digital in channels. 2 of those are available on the front panel and all 16 are available on the rear panel. Then every amplifier has 3 digital analog out plugs or 3 channels available on the interface. These are the command out channels of the interface. However, the interface board itself has 8 analog out channels, and 3 of those are available on the built-in version of the interface. When you look at the standalone interface, you see that all 8 analog out channels are available right here. Then we have 5 free AD channels on every amplifier. Every amplifier, single channel, double and quattro, has 5 AD in channels. Whereas the standalone interface has a total of 16 analog in channels. But like I said, for the built-in interface board, there are 5 available on the front panel of the amplifier. Here are the 16 analog in channels of the standalone. And then of course the interface needs to be connected to a 3.0 port on the acquisition computer. It does not work with the 2.0 port. Okay, this concludes the video. One last slide quickly. The HEKA support team, Martin Oberhofer and Barbara Vardas in Germany. I myself are located in Chicago in the US. If you have questions, HEKA related or general patch clamp questions, please feel free to send an email to support@heka.com. And for sales related emails, please go to our website, heka.com, and under sales, you find this country specific email address where you can send sales related questions to. So we wish you exciting and successful experiments, and thank you for watching.